Hello students, welcome to another tutorial on vectors. In this video, we're going to look at this question that I left you guys with in the previous video. So the assumption I'm making is that you've watched the other videos. If you haven't, I advise you to watch that, especially the introduction, since it points out how I break down these vectors. But if you have, or if you have a working understanding of how to get the vectors, how to get the components of the vector, then we can go on together to see how we can determine, how we can find the solution to this particular question. So let's see what they're saying. So they're saying we have a displacement d of magnitude 100 meters from the origin at an angle of 337 degrees above the x-axis is a result of three successive displacements. D1 of 100 meters along the negative x-axis, D2 of 200 meters at an angle of 150 degrees above the x-axis, and the displacement D3. Find D3. So how do we approach this question? Well, much the same way we approach the other questions. All we have to do is identify the number of vectors that are combining to give us the resultant. And then in this case, of course, notice that they start by giving us what the resultant is. So we want to find D3. What is D3? We're given three vectors, D1, D2, and D3. When these three vectors are combined, their resultant is that vector D. So that is a result of the three vectors, D1, D2, and D3. So if you were to make a table to collect your information, what you should see first of all, maybe before I even make a table, let's look at what we're given. So first, if you look at the vector D itself, which is the resultant, of course, what you see is that they're saying the resultant, vector D, I'm going to draw this a bit better. Okay, so what they're saying is that for the vector D, okay, I think that's better. Let's try to improve the vertical line. I think that's better as well. Okay, so what they're saying here is that our resultant D is 100 meters, first of all. Apart from that, it is in a direction of at an angle of 37 degrees above the positive x. So this is the positive x. If I was just to include a few things here, so this is my x-axis, that is my y-axis. So what they're saying is we have above the positive x, meaning that we are going up until when the angle is 37 degrees. So expect this vector to be here. So this is the vector D, and it is 100 meters. The angle here, 37 degrees. Okay. Now, apart from that, how about the other vectors? Well, the vectors which combine to give us this displacement D are three of them. One is D1. So if we look at D1 again, so what we have for D1, so these are going to just be rough lines. So you guys will forgive me if I don't read that straight. Okay, so again, this is the X, this is the Y. For the displacement D, or for the vector D, what they're saying is it is 100 meters along the negative X, the negative X-axis. So I'm only making these sketches or these graphs so that you guys, it will be easy for you to see how I resolve these components. Okay, so for this one, what are they saying? It is 100 meters along the negative X. This is positive X along this line, negative X is along this line. So they're saying it is this vector D1 is 100 meters along the negative X, meaning that we have no angle here. The angle is there, but in this case, of course, it just moves along the negative X. So if you're going to measure the angle, if you wanted to use the angle, you'd have to measure from here, and you should see that the angle here is going to be 180 degrees. Okay, so this is D1, and the value is 100 meters in that direction. So of course, this is going to be negative since it is going to the left. Okay, so of course, here we have D1, and then here is the resultant itself, capital D. And then what else? We have one more vector which is given, and that vector is D2. What are they saying for D2? Well, let me first sketch my graph. So for D2, what we have is something like that. Then we have this, the x-axis, the y-axis. So for D2, the description is D2 is 200 meters at an angle 150 degrees above the x-axis. So above the x-axis. Well, they haven't specified whether negative or positive, but the fact that they haven't said negative, it means that this has to be the positive x. So we're starting from here. So 150 degrees above the positive x. So we're going to start from here until we make an angle of 150. Now, when I reach this line, I know I've only made 90 degrees because, of course, these planes will make a 90-degree right angle triangle. So I haven't yet made 150, so I have to continue a bit further. But then I know to say that if I came all the way up to this line, the angle would have now been 180. So definitely 150 is before 180, but it is after 150. So I'm going to say this vector is going to be somewhere here. So that this is my 150 degrees. Okay, so they're saying it is 200 meters at an angle 150 degrees. So that is D2. Okay, now just remove this part. Okay, done. Okay, now what I want us to find is towards the end, the third displacement that is combined with those two is D3. But then we want to find what D3 is. So in most cases, we would have been given what D1, D2, and D3, what they are, and then we would have been asked to find the resultant that we get when the three combine. But now we're given what they give us when they combine, which is D capital D, which is this one. But they want us to find the third vector which combined to give us that resultant. Now, how do we do that? Well, what we have to do is create a table. So we want to create a table which shows us just the components so that it is easy for us to evaluate them. Why are we doing this? Because vectors only add in their components. We can't just go right ahead and add the vectors without breaking them down into their components. So we're going to make a table. We've identified that there are three vectors which combine to give us a resultant. So here, we're going to have the resultant itself, that's capital D, and then we have the three vectors. So we have D1, D2, and D3. Now, what we have here is this side, we're going to have the x component of each vector, which is going to be in this column. And then in the other column, we're going to have the y component of each vector. So again, here I'm assuming that you've already watched the previous video or previous videos where I took some time to explain what is happening here. So now our focus is just seeing how we apply the same methods to work out this particular question. Okay, let's see how it goes. For the first one, D, which is capital D, the resultant itself, 100 meters, 37 degrees above the positive x-axis. You guys should be able to see that the x component is going to be this one here. And of course, it is adjacent to my angle, so I'm going to use cos for this, this vector. So I'm going to use cos, so it is 100 meters cos 37 degrees. So again, I already took time to explain how you get this. Of course, if you're not sure, you can still use Pythagoras theorem, since if you did this, you make a right angle triangle. So you should see that cos is adjacent over hypotenuse. So it's going to be whatever the x component is divided by the hypotenuse. So of course, when you make the x component subject of the formula, you're going to end up with 100 meters or 100 cos 37 as your x component. Okay, so if we go back here, we've seen that this is going to be 100 cos 37. For the y component, when we go back to our vector, for the y component, it's this particular line. So if I denote it by y, we see that it is opposite to our angle here. So we're going to use sine. So of course, sine 37 degrees is going to be equal to y over the hypotenuse. Make y the subject of the formula, you see that it comes out as 100 sine 37. So this comes out as 100 sine 37. Next up, D1, what is happening there? D1, all of it is in the negative, along the negative x-axis. So if you wanted to use the angle, of course, you started from there, meaning that to get the x component, you'd have to say 100, the vector itself, cos the angle, since it's measured from the positive x. Don't worry about SOHCAHTOA here for you to start thinking about the right angle triangle. Since I'm measuring the angle from the positive x anti-clockwise, It means that I'll use cos to get my x component and I'll use sine to get my y component. But I always advise students not to memorize that. I prefer you make observation, especially if the right angle is possible to get from there. But here, of course, we're not making a right angle triangle. So we're just going to use that, that observation. So this is going to be cos 180. Of course, notice that this is going to be, since cos 180 is going to be -1, so this is going to be -100. And then for the y component, we're going to have 100 sine 180. Sine 180 is 0, so this comes out to be 0. So the y component is going to be 0 by the math. The x component is also going to be -100 meters. But when we're working out these questions, the best way of dealing with such a thing is just by observation. So of course, if you observe what is happening here, notice that this vector, all of it is along the horizontal axis. So just by that fact, it means that it has no displacement in the vertical axis. If it has no displacement in the vertical axis, then its component in that axis is 0. And then since all of it is in the x-axis and where's in the negative x-axis, then it means that the x component is going to be -100. So with that in mind, the x component, we get -100. The y component is this, it has no displacement in that axis. We get it as just a 0. So again, it's up to you which method you want to use. You can use observation, as I just did here, or you can use the math that we did here, taking into account that the angle is 180 degrees. But I always prefer just observation. The vector is in the horizontal, meaning it has no vertical component. Okay, so we've got D1. We move on to D2. So for D2, there are 2 methods you can use to get D2. So this is D2 here. So what you should see here is that the angle given here is measured from the positive x-axis and it is anti-clockwise. So meaning for such an angle again, you can use the fact that cos will give you the x component and sine will give you the y component. That will give you an answer which will work. But again, you can still just say, okay, this is going to be my x component. You can do it from here, meaning that is your x component, and this is going to be your y component, so that you form a right angle triangle. If you do this, then it means that you have to find this angle which is here. Since the whole lot is 150, and you know that from here, the red part just here, this part is 90 degrees. So less 90 from 150, you should see that the angle that makes this triangle is going to be 60 degrees. And from there on, when you observe the relationship between the y component and the x component here with the angle, the 60 degrees angle, you should see that the two sides, that side I mean and the angle, the x component and the angle, they are opposite to each other. Because they're opposite to each other, I'm going to use sine. So sine the angle 60. And the vector itself, in this case, the vector itself is 200. Okay, so let me just bring back the vertical line. Okay, so yeah. So here we're going to have 200, the vector itself. And since the side I'm looking for or I'm finding is opposite to my angle, I'm going to use sine. But using this method has one limitation. You have noticed that this vector or this component is pointing to the left. So you have to bring down that negative there. Since it is pointing to the left, you have to do this manually. The next part is to find the vertical component. The vertical component is this one here. It is pointing up. So let me use the different colors so that you're able to see it properly. This is the vertical component. Again, when you look at this component, it is adjacent to our 60-degree angle here. So because of that, we're going to use cos, because cos gives us adjacent. Hence, for this one, we're using cos 60, so it is the vector itself, which is 200, cos the angle 60. And since this one is pointing up, we know to say this is going to be positive. So this is the method I always prefer to use when I'm finding these vectors. Understanding how it works is best because there will be some other questions where for you to start thinking about getting the entire angle from the positive x anti-clockwise, it might be long and it might be tricky for you. But if you're able to do it every time, then you can use the other method. Well, for For learning sake, let's also look at how the other method would have gone. So for the x component for the other method, all we're saying is it's a memorized thing. Cos gives you the x component, so it's the angle itself, 200, cos the vector, cos the angle, measured from the positive x. The angle measured from the positive x is all the way from here until when you reach the vector, meaning the angle you're using is 150. And then, of course, if you get the y component, you're using sine. So it's the angle of the vector itself, 200, sine the angle. Again, the angle is measured from positive x anti-clockwise. So now this method, the main advantage of using this method is there is no need for you to start observing that the x component is going to the left. The angle will place that negative for you. Notice that if you evaluate this, the answer you get will be exactly the same as this one, where we place the negative by observation. Okay, so it's up to you. You can use these. Let me highlight them. You can use these components to find by this, or you can use these ones. Up to you. Okay, so for me, I'm going to use the ones we got. I can even use the first ones, doesn't matter. Okay, so how does it go? So this one, the x component, we have negative 200 sine 60. The y component, we have 200 cos 60. Okay, now we want to find d3. Nothing about d3 is given to us, so I can just assign variables here. I can say d3 in x, or I can just say x in y. So okay, let me just say this is x and this is y. Of course, x here represents the x component of d3, y represents the y component of d3. So now we want to find what d3 is. How do we find it? Well, what we have to remember is these components combine such that their sum gives us the resultant, the component of the resultant in that direction. So in other words, if we did this, the first one, the x component of d1 plus x component of d2 plus the x component of d3, what we expect to get is the x component of the resultant. So from here, we can simplify this to get what this x component, because it's the only variable here. So if we make it the subject of the formula, notice that we end up with 100 cos 37. And then the 100 crosses, it becomes positive. And then this crosses the other side, it also becomes positive. So the 100, I didn't include it, let's write it. Then this also becomes positive 200 sine 60. So we can simplify this. So when you simplify this, you should see that you're going to get, that's going to be 3, 5, 3. This is a magnitude, so this is going to be in meters, of course. Okay, so but of course, here we're just getting them. We're just getting the components. This is not our final answer. So this is just the x component of d3. Now we need to get the y component of d3 using the same method. So again, it's 0 plus 200 cos 60 plus y is equals to 100 sine 37. Then work it out for y. How will it look? So we have 0 plus 200. So these are the y components. So that's 200. What was this working with? And that's cos 60. Okay, this was given by cos 60. Hope I used the correct one. And so sine 60, nice. Okay. Okay, so here what I have is 200 cos 60 plus 1 is equal to the resultant, 100. That's 100 sine 37. So again, we're making y the subject of the formula. So what we're going to have is y is equals to 100 sine 37. 0 is just a 0, so we'll skip it out. Then we have 200 cos 60. So if we simplify this, we're going to get the value of y as negative 39.8. Okay. Now that we have the x and y component of d3, we can then move on to get the resultant. Now I want you guys to notice one thing here. See, if we tried to sketch d3 by looking at the components that we've obtained. Notice one thing. Well, the components, this is y and this is x. The component is such that the y component is negative. So if I was to sketch the y component, so first let's look at where's the x component. X component we found it as 353. So positive. So what you have is 353 coming there. So this is the x component. And for the y component, it's negative. So the x component was positive, so we went to the right. The y component is negative, meaning we have to go down. So we're going to go down in this direction. So these are the components of this particular vector. So the resultant that we're looking for is going to be a vector that starts from here, going all the way up to there. So notice that here again, we're forming a right angled triangle. So this is where our x is. This is where our y is. Okay, so let's finish this. This is axis. This is axis. Okay, so with that in mind, the point here is that to get the resultant vector r, notice that, let me not say resultant vector r, let's say resultant vector d3. To get this resultant vector, notice that since it is a resultant of two short ones, it has to be d3 squared is equals to x squared plus y squared, so that this resultant we're looking for is just the square root of x squared plus y squared. Since we already know what the x and y, what they are, so x we found it to be 353, so square that, plus the y component, we found it as negative 39.8. So notice the negative as well, it has to be squared since it's the entire component y, which is squared. So of course, everything under the square root, evaluate this, we get 355 meters as the magnitude of our vector d3. So once we've got the magnitude, you see, it's not enough to just state the value of the displacement. We also want to specify the direction. So some questions will tell you to say find the vector d3. They don't say find the magnitude and direction, they say find the vector. You see, just by saying that, you should not to say to give a vector, you have to give the magnitude and you also have to give the direction. Some questions will specify to say, find the magnitude of the vector. When they say that, then they want you to just find the value like this one without specifying the direction. In this case, they're saying find the magnitude and direction. They're saying find the vector d3. By saying that, they want us to be going to find both. That is how we state the vector. So we have the vector, we found it, the magnitude part, that's 355 meters. How about the direction? Well, for the direction, again, you come back to this triangle we made. Notice that the angle gives the direction. So this is the angle here. Let me call it theta. So notice that this angle, we're going to relate it to the two components that we had, the x and the y. And they'll relate by tan. Tan is equals to opposite over adjacent. Yeah, opposite over adjacent. And notice that I'm using that ratio because this is a right angle triangle. So tan is equal to opposite over adjacent. So tan the angle theta is equal to the opposite, which is y, over the adjacent, which is x, implying that the angle itself is tan inverse of our y over our x. Okay, but what was our y? What was our x? So our y was negative. That was 39.8. Our x was 353. Okay, so if we evaluate this, we see that our angle comes out as 6.43 degrees. Okay, so we get our angle with a negative there, of course, at 6.43. So we have one thing that we have to keep in mind here. This negative kind of say that, hey, we need to check this value. In most cases, a negative means that we measure this angle in the opposite direction. Angles are supposed to be measured in the anti-clockwise direction. So for us to get a negative, it means that this angle was measured in the clockwise direction. So it was measured in this direction, but we know angle is supposed to be measured in the alternative direction, clockwise direction. So if this is our vector, we have to start from the positive x, go anti-clockwise until when we reach our vector. That is how we specify our direction. Again, it even makes sense. When you look at our sketch here, you notice that our angle theta is this angle here, which is in the fourth quadrant. So this is the 6.43 degrees. So to get the answer now, to take this as an answer, we want to measure this angle, measured from the positive x, but anti-clockwise. So I want to start from here, move in this direction. Sorry, just erased everything. Start from the positive x, move anti-clockwise until when we reach our vector. Notice that all that we have to do is, since the full rotation makes 360 degrees, so from 360, we're going to subtract this particular vector. So we see that to get the answer now, then you've got it fine. We have to subtract from 360 degrees. We're going to subtract, not the negative. We're not going to, don't say we subtract negative to say, again, here you want to say negative 6.43. No, I'm not going to do this. See, this negative, which comes with the 6.43, was just telling us to say this angle was measured in that direction. But of course, here we just want to find, the piece, the remaining piece, when the other piece, the 6.43, is removed from that, that 360. So what you see from here is that when you make the subtraction, you're going to get the angle measured from the positive x anti-clockwise as 353.6 degrees. So this becomes the direction. So we can conclude that our vector D3 is of magnitude 355 meters in the direction 353.6 degrees anti-clockwise from the positive x. So this is how we work out this particular question. Okay, so hope you guys were able to follow how we work out this particular question or this type of questions. So it's the same methods that we keep on applying. Just watch out for a few common tricks that you have to use sometimes. Of course, this was quite straightforward. So in the next question, we are going to look at another simple question. So we're going to look at this question. You guys can try it out beforehand. So otherwise, I will see you guys in the next tutorial. You can leave your comments in the comment section. You should be able to reply to them on time. If you've got any questions, you can forward them to me. All right, you guys, we'll see you in the next tutorial. This was your tutor.